Agent-to-agent communication sounds simple until the agents do not live in the same runtime. One agent may be built by another team. One may run behind a service boundary. One may be owned by another vendor. That is where A2A fits. It is a protocol boundary for agent interoperability. The durable ideas are discovery, capability descriptions, task exchange, task state, messages, and artifacts. Do not think of A2A as a fancy function call. Think of it as a contract between pairs. The first concept is the agent card. It tells a client what an agent claims to do. The card has a name, a URL, supported skills, and input or output modes. In the teaching code, each skill has tags. The registry can ask a simple question. Which discovered agent supports the refund capability with text input? That is the important design move. The client should not route work because it knows a private class name. It should route work because a discovered contract declares the needed capability. After discovery comes a task. A task has an ID, a target agent, a state, messages, and maybe artifacts. Messages are the communication. Artifacts are outputs with identity. A report, summary, patch, plan, or answer can be represented as an artifact instead of being treated as loose chat text. The state field matters because remote work may not finish immediately. A task can be submitted, working, completed, or failed. That lifecycle is what lets the caller manage work without pretending the remote agent is local. A2A is not the same as tool calling. A tool is usually inside one agent's control surface. The agent invokes a capability, gets a result, and keeps ownership. A2A is a pair boundary. The caller is asking another agent to do work through a protocol contract. That other agent may have its own tools, memory, policies, and lifecycle. A useful shortcut is this. MCP connects agents to tools and data. A2A connects agents to other agents. Use A2A when interoperability is the real problem. Cross-team agents, cross-framework agents, partner agents, or agents that need a stable network contract are good candidates. If all specialists live inside one application, start smaller. A type tool wrapper, queue, or graph may be easier to operate. The cost of A2A is operational surface. You need identity, authorization, retries, timeouts, compatibility, and task lifecycle handling. Add that surface when the boundary is worth it. Once tasks cross an agent boundary, normal distributed system concerns appear. Who is calling? Is the caller allowed to request this skill? How long should the remote agent work before the caller gives up? Versioning also matters. An agent card is a contract, and contracts change. If the remote agent changes the skill name, input mode, or artifact shape, callers need a compatibility story. Artifacts need the same care. Do not treat every return blob as trusted text. Preserve artifact names, types, and provenance so downstream agents know what they are consuming. This is why A2A should be deliberate. It solves interoperability, but it also asks you to operate a real boundary. Use this as the interview answer. A2A is a protocol for agents that need to discover each other, exchange tasks, track task state, and return messages or artifacts across a boundary. It is different from a tool call because the remote agent owns its own behavior and lifecycle. It is useful when agents cross runtime, team, or vendor boundaries. And the caution is just as important. If you do not need interoperability, do not add a protocol boundary just to make a local workflow look more distributed.